Let's take a look at contingency tables and what probabilities we can learn, or percentages and proportions we can learn from the group. I'm going to use Stapplet.com, and this will be a categorical variable in multiple groups. The way it's arranged here will be exactly how we want to set it up here. Although I'll show you that we could get different information and highlight different things if we configure it in different ways. At first, I'm just going to enter this in exactly how we see it in Stapplet, putting intent to buy, yes or no, on top. With all these data in, I can begin analysis and it will give me a graph. And you'll notice that this is what I was commenting on, is that it's highlighting the freshman and sophomore, not the intent to buy. So actually I did this label wrong. This should be class by intent to buy. We usually do y by x or y versus x when we do this. And here we're making the y value the class, which doesn't really make sense. It would make more sense to arrange it by class in the bottom, look at freshmen versus sophomores, and see how that yes-no comparison looks. So first I'll just answer this question and then I'll rearrange it in a slightly better way. This is what percent of the group intends to buy, and we can look at that result here by looking at the total of yeses divided by the grand total. So 127 divided by 282. That would be about 45% for this problem. Oh, it says 2 decimal places. I do tend to miss that. So this would be 45.04. And you can fill in the totals there. But let's reframe this a slightly different way and then look at some probabilities that we can learn. So like I said, I'm going to reframe it. I think it makes more sense to study intent to buy by class, which puts the intent to buy here. And all it's going to do is flip some things in the table. So the freshman and yes was in the top left, sophomores and no was in the top right. What we'll flip is these two, which actually are the same in this example. So that makes it really easy to rotate this or pivot this to a different focus. Now, I really like what I see here. I see a different class side by side, looking at the resulting statistic of do they intend to buy, qualitative, turned into percentages. To learn from it, with the mosaic plot, we can look at the relative comparison of freshmen and sophomores, as well as the percentages, yes and no. Although I think my favorite is going to the side by side with raw frequency. So now we can both compare these groups relatively speaking. Sophomores, there's more than freshmen, but we can also look at how they relate. There's more of a distinct difference with sophomores, yes and no answers versus freshmen. And now I think I also like what I learned from this better. If I wanted to figure out the percent who said yes, I actually get that number right here. So changing the focus to we would say the response variable gives us more meaningful percentages. We also get more meaningful percentages here. These are going to be called conditional probabilities. So right here we have the percent of freshmen who intend to buy. 60 over 127 is the percent of freshmen. Using the right notation for that, I'm going to insert an equation. That would be the proportion of freshmen who intend to buy. So the proportion who intend to buy given they are freshmen. That is how we label that conditional probability, or it's sort of an out of probability, a percent of a subgroup. And in this one, it is looking at the percent of freshmen who intend to buy, which is 60 out of 127, or 47.2% That's just to show you the notation that would go with that. You might see some other notations like the and or probabilities, but those really aren't as useful to us here. But we could do an and probability. For example, the probability or percentage of people in this survey who are freshmen that intend to buy, in other words, meeting both criteria. That would be that probability. This one we call an intersection. This is just going to be the number of people who meet both criteria, who are basically where those two things intersect. That's 60 people right here. But since we're talking about the whole entire group, we divide back by this whole probability. That one's not going to be displayed within this table. 60 out of 282 for that. So that one's about 21.3%. And another one that you'll see a lot is very similar to this, but with an or. So we have the proportion of the sample who are freshmen or intend to buy. And I tend to think this isn't super helpful. It is called the union. And so we would look at those who intend to buy. There's 127 there. Or the person could be a freshman and land in this group as well. We've already calculated 60 of the freshmen. We need another 67. So you could look at it as 60 plus 67 plus 67, or 127 plus 67. And again, we're dividing by the whole entire group. This one will be about a 68.8% of the group. It does show you that an or will be more inclusive, include more people than an and. Or is union, so we're combining groups into one big group, and is intersection, so we're looking at only the overlap there. And if you ever see addition and multiplication rules, they do relate these probabilities, but we don't really need them for the types of things that we do in this class, which really, I think, goes back to this first one. If we can compare these variables, we would do it by comparing how this intent to buy changes as we look at different groups. So we can see how the percentage of freshmen who intend to buy are 47.2%. Sophomores is a little lower. It's not a huge difference, but it shows that there's a dependency or a connection between these variables. It's not going to be completely random or completely unrelated.